Welcome to a board looking at what happens when we have a resistor and a capacitor in series. And that happens in a lot of timing circuits we get in electronics. What have we got on the board? Down this left hand side we've got an ammeter so we can see the current, a switchable resistor and then a switchable diode. And then we've got exactly the same down this right hand side, and across the two we've got a capacitor. The value of this capacitor can be changed via this switch here, and the values of these two resistors, which are always the same, can be changed by this switch here. We've got 4 voltmeters, and if I turn the circuit on we can see them light up. We've got this showing the supply voltage. The one here on the left hand side is the voltage from ground to the point between R1 and the capacitor. One here on the right hand side is the point between R2 and the capacitor and ground. And then the one in the middle here is showing us the voltage across the capacitor. So let's see what happens when we charge up a capacitor. I'm going to switch this diode in to the circuit, and then I'm going to switch R2 in. So we can have a flow going through the ammeter, across through the capacitor, down this way here. Watch the ammeter as I switch it on. There it goes. A high current to start with, and then it's going back, and the voltage across the capacitor is slowly climbing up. And as it does so, the meter here on the right hand side is showing the supply voltage. We've got no current anymore flowing through R2. If we've got no current, then we've got no voltage difference. So these two are showing the same. On the left hand side, the 0.4 is the voltage we get across a diode. So it's charged up that capacitor that way. I'm going to discharge the capacitor by pressing the discharge button, and I'm now going to charge it the other way. So I'm going to switch on the diode on this side of the board, and I'm going to turn on R1. And we've got current flowing the other way, so the voltage recorded on this meter in the middle is now a negative voltage because it's being charged the other way. Now, a lot of electrolytic capacitors you cannot charge both ways, and if you do, they will explode. So I've had to use special capacitors here which can be charged both ways, and they're called bipolarized capacitors. So there we have a charge across the capacitor now, with this side being nearly 4.5 volts higher than this side. Now what's going to happen is I'm going to turn off the connection running down here, and in a moment I'm going to turn on this resistor here. So we will have R1 connected to R2 through the supply line. So we'll have a loop of these 3 components. Watch the ammeters as I turn it on. We've got a current coming out of this side of the capacitor through that ammeter across the top and then back down, and that's discharged the capacitor, which is now flat. And we saw one ammeter swing one way and the other ammeter swing the other way as the current flowed round the circuit. Now I'm going to do that again. Just going to turn that one off, turn this one on. We're going to charge up the capacitor again. Wait for it to come up to the full voltage. But when we do that again, I'm just going to change the value of the 2 resistors to a higher value. So things are going to happen more slowly, because this time we're not going to look at the current flowing. We're going to look at these 2 meters here. So I'm going to disconnect here, and I'm going to put R2 into the circuit. Here we go. Now look at this. We've got the meter here on the left climbing up to nearly 7 volts, and this one dropping down to 3 volts. And slowly, as the voltage across the capacitor drops, the meter here on the left is coming down to the 5 volts, and this one here is coming back up to 5 volts. So what's going on? Well, we had a current flowing through that resistor, through this resistor, back to the capacitor. Now, if we have a current flowing through a resistor, we're going to get a voltage across it. And as these 2 resistors are the same, we're going to have the same voltage dropping across both resistors, and that's going to be half what was across the capacitor. That was about 4 volts, so we'd have 2 volts across there and 2 volts across here. This supply line was held at about 5 volts, so it meant that the part of the circuit between R1 and the capacitor went up to 7 volts, and this point here dropped to 3, and then they slowly came back to their 5 volts when the capacitor discharged. So you can see all sorts of strange things happening to the voltages when things are switched in and out. Let's look at something else. Just going to turn those off. We are going to charge the capacitor the other way. So I'm going to charge it like this. We've got a current flowing down, a much smaller current because we've got a higher value in the resistors, through the capacitor to ground. And you can see it climbing slowly. On the right hand side here I've got an oscilloscope. This is showing the voltage across the capacitor, and you can see that arc. And this curve has a name. It's called an exponential curve. And what it means is that things happen very quickly to start with, and then as time goes on they get slower and slower and slower. And that's a very important part of the way that capacitors charge. So now we've got 4.2 volts across the capacitor. It might go up a little bit more, I don't know. We've got pretty much the supply voltage on this right hand side, so it's going across that, and then this one is switched in to bring it near to ground. I'm now going to switch this diode in, and that's going to pull a point in the circuit between the capacitor and R2 down to nearly 0. See what happens to the voltage on this left hand side. Because we've still got 4 volts across the capacitor, with this right hand side being positive, it's pulled the voltage on the left hand side of the circuit down to below 0. And that's why we've got the diodes in, really, to stop the current being changed by current flowing effectively back up to this point here. So we've now got a negative voltage across here because we changed the voltage on this right hand side, and it's pretty much going to stay that way until I introduce R1 in the circuit, and that's going to have a current flowing back this way to reduce the voltage across the capacitor back to 0. So now I've switched that on, we've got a current flowing, and quite quickly we've got this going back to 0. We've got currents flowing on both of these now because they're connected to the ground via the resistor and the diode. So we've got a permanent flow of current going through both sides. But by charging the capacitor and then changing the voltage on one side, it changed the voltage on the other side of the capacitor. 3 components, but an awful lot going on.